Hi, welcome back to Mat140. And today we're going to cover section 8.1. It's on page 387 of your book. And you have a book. 387. Okay. And so on 387, we're going to discuss what we call computer basics. Okay. Computer basics. Percent basics. Sorry. Head's in a mess here. All right. So the first thing we want to do is change some percents to decimals. Very simple to do. Number one, add a decimal. Think of your percent as a monster. He's going to attack you. You're running away from the monster. You always go two places. Two places. And so this new number would become 0.36. Percents mean an average, based on 100. So percentium means per 100. And so if we want to compare different things, like maybe our kid made 32 out of 40 on a quiz, and I took another quiz and he made 17 out of 28. We want to see, okay, how can we compare those two numbers because they have different bases? One's 28, one's 40 or whatever. And so how do we compare them? So we can convert them to percents, and then we could look at the percents. So that's why percent is useful. But when we're doing most of our calculations, we want the number to be a decimal rather than a percent. Percents are pretty to look at, but to operate with them, we need them actually in decimal form or a fractional form or some kind of form. All right, let's try the next one. We want to move this one two places. We have a decimal point, so let's just move it over two places. Always two. And this would be 0.193. So 19.3% is 0.193 or 193 thousandths. Okay, what if you had less than a percent? You got 0.5%. Well, that's okay. We're still going to move it two places. We don't have enough zeros, so we're at another 0.005. So you're always moving the decimal point to the left two places. Left two places. But I kind of think of it as moving it away from the percent and then getting rid of that percent sign. Get rid of that percent sign. Okay, what if you have a decimal? We did some calculations and you want to write it as a percent per 100. You could multiply it by 100, or we can simply move our decimal point over two places, and this would give you 29. And then we add the percent symbol. Your decimal point would be behind the number. So the decimal point always goes behind the number. If there is no decimal point, we put it behind the number. Okay, here we ended up with 29%. Here's another one, 0.035. Again, we're going to move it just two places to the right. Two places. So you're moving it towards the percent sign because you want to create a percent. So that'd be 3.5%. Finally, 2. Let's add a decimal point, and we're going to move it two places. Get two zeros there. And now we can move it, and we have over 100%. We have 200%. So we can have percents greater than 100%. We can have percents less than 1%, So if you want to create a percent, you move towards the percent. If you want to get rid of a percent, you move away from the percent. Now, here I have some fractions, and I want to convert these to percents. So the first thing I want to do is I want to convert them to decimals and then change the decimal to a percent. So I'm going to use my calculator. To do this, I'm going to take the top number, 3. Let's turn this on first of all and clear it. I'm going to take the top number. I'm trying to get this so there. It's not too bad there. Take the top number. Think of this as a division bar. 3 divided by 8. That's what it's really saying. 3 divided by 8. So we write it down. Hit equal 0.375. Now I want to change that to a percent. So I'm going to move towards the percent. Percent is going to go at the end of the number here or wherever. So it's going to be 37.5 and then the percent symbol. So 3/8 is 0.375, 37%. What if you get a real strange one? You know, maybe 82 out of 196 people did this, and we're trying to figure out what percent is that. Okay, 82 divided by 196 equals. Well, here's one that just doesn't end. It just keeps on going. But we're probably just carried out 3 decimal places, 0.418. And because there's a 3 behind the 8, we're not going to round it up. So we're going to keep it an 8. Then we're going to move it 2 places towards the percent sign, 2 places to the right, 41.8%. It's just that easy. We're just moving it 2 places, always 2 places to the right. Let's do the right thing. Let's move it 2 places to the right. Okay, and here's maybe you took a quiz and you got 37 out of 40 and you want to know what that was. 37 divided by 40. You see that came out to 0.925, but that doesn't mean too much to you. So now we change it to a percent, 2 places over. That means you got a 92.5%, which is probably an A. You know, looking at it this way, you're not sure. You know, you did pretty good. But what is that as a percent? Well, this is as a decimal. So let's move that decimal point 2 places, and now we got a percent. So those are our basics that we're going to use. To change a percent to a decimal, move away from the percent 2 places. To change a decimal to a percent, move towards the percent. Change a fraction, make it a decimal first, then convert it to a percent. Okay. All right, here's another problem that they have in your book. This is on the next page. It says, according to the Office of Management and Budget, in the 1970s, the United States government spent $82 billion for defense, and the total federal budget was $196 billion. 45 years later, 2015, they spend $598 billion for defense, but now the budget, federal budget, the total budget is $3.8 trillion. So how does this compare to spending in 1970 for the defense as compared to 2015? We know they're spending a lot more money. So what I did is I wrote this problem out, put it over here. In 1970, they spent $82 million of the budget. That doesn't sound right. This should be, what do I have this? 59 billion. Something is not quite there. It was, what was the budget in there? 196 billion. I don't know where I got this number. Making up my own problem here. 196 billion. And now they're spending 598 million, but the budget is 3.8 trillion, which is 3,800 billion. I moved my decimal point over 3 places actually on that one. So that's what 3.8 trillion is. It's 3,800 billion. Okay, so how are we going to compare these? Well, we're going to make a fraction out of it. 82 to 196. because we wanted this in millions, but we want this in billions. We want this in millions, 598, but we want this in billions, 3,800. Okay, so now what I'm going to do is I'm going to divide this by 82 divided by 196. I'm going to change that to a decimal. And I guess you can't see that too well. Sorry about that. It's about 0.418. We could round it off to 42%. You know, we just leave 418, okay? This came out to be 0.418. So let's change that to a percent. 41.8% was spent. Now let's try 598 divided by 3,800. There's no good spot, huh? And that's 0.157. Boy. 157. Which we're going to move over 2 places. So that's going to be about 15.7%. We're going to move this over 2 places and 2 places here. So you can see the spending was much higher in 1970, even though money-wise, it was much less, 82 million compared to 598 million today. But the total budget is it's also increased. So what was going on in 1970 was probably a little bit of Vietnam, and we were spending quite a bit on the war. Today we're spending a lot less on military budget. Okay, here's another one. We want to find a percent of increase. It says in 2010, Red Bull cost $18.02, that's 12 pack. And then in 2015, it was $19.58 a 12 pack. And we want to find what is the percent of increase. What is percent of increase? And that's what we're trying to find. To find percent of increase, there's a little formula. First of all, you want to find the change. When we're looking for change, we want to know how much did the amount change. We want to find the difference, or we want to subtract. So the change between these two amounts, we're not worried about the years, but we want to find out how much, what was the percent of increase of the cost, you know? I should have maybe put of cost. So the percent of increase is 1958 minus $18.02. Okay, and without using my calculator, that's going to come out to about $1.56. Now, our formula is going to call for the change. And I like to write it this way, divided by the starting amount. Start amount. Okay, and this will give you a percent of increase each time. So the change was $1.56. We just calculated. And now we're going to divide that. I'm doing a little different from the book. And the starting amount was the amount back in 2010. That's when they started putting it on the market, $18.02. So now if we divide that off, and I'm going to use the numbers they have in the book, save a little bit of time, but you could just divide that on your calculator. They come up with 0.0866. So we want to change that to a percent. That would be 8.66%, or we might just round that off to about a 9% increase that it's gone up. Over that period of time, over 5 years, it's increased by 9%, the cost. So to find percent of increase, which we do quite often, percent of increase is equal to, first we find the change in the two amounts, Big number might take away the small. You want to keep it a positive number. And then you want to divide that by what was the original price, the starting amount, the original. Okay, let's do a variation on it, but it's pretty much the same idea. Here's a dealer, and we're going to say he's honest or not. This is in your book. It says Mat140 has an end of the year, and they give you a TV. The TV ads are saying that they're selling the car at 5% over the dealer cost. And you want to find out if this is really true. And you go to pick out a model, and the guy says, hey, we can give you a super deal, 5% over cost. This car costs $21,339. That's what we have to pay for this car. But we're going to sell it to you for $23,302. We have to make money, but we're only going to make 5% over our cost. Okay? So is this a good deal or not? Well, to find that out, what we're going to do is find, we're going to do pretty much the same thing. We're going to find the change, 23,302 minus 21,339. We don't want to just put these over each other because that's not going to work. We want to find the change. How much did the price change by? And if we do this, this should come out to be $1,963. That's the difference you're paying between his cost and what you're actually paying. Okay, but what you're going to do is you're going to find the percent of increase. Percent of increase. And how do you do that? You put the percent, or the change, I should say, you put the change over the starting amount. Well, what would you call the starting amount? On this one, you would call it the dealer's cost, because that's what it started out as, the cost of this car. So 1963 divided by the dealer cost. And this should give you the percent of increase. And we find out that's 9.2%. So they're lying to you. It's not 5% over the dealer's cost, it's 9.2%. So I asked myself, this wasn't part of the problem, but what should he sell the car to you for? You're saying, hey, you're cheating me. So how would you find it? Well, we can use the part is equal to the percent of the total. This means the part, which was this 1963, should be what he's really selling it to you for. So we're going to take 5% because that's what he said he would sell it to you. So the part, we call it P for part, is 5% of means times the total. The total would be the dealer's cost, not the price you're going to pay for it, but the dealer's cost right here, 21,339. Okay, so we're going to find that out, but here's a percent. We can't use it. So again, we're going to move this away from the percent. So we're going to take 0.05 times 21,339. See, pretty to look at, but we need impractical to use. So I'm going to multiply 0.05 times 21,339. 21,339. And that comes out to 1066.95. Now, that's not what they're going to sell the car to you for, obviously, you know. That's how much the discount is going to be, or the amount that they're going to sell it above cost. So what we're going to do is take the 21,339. That's what the dealer pays for it. We're going to add this amount. That's how much you're paying above the cost. Remember, before you were paying 1963. Now you're paying 1066.95. So let's see what this car should cost you. I already got it in the calculator, see? So I'm going to add that to 21,339 equals. So this is what they should sell you the car for. If they're selling it at 5% above cost, it should cost you $22,000, not $23,000. So almost, like, well, you're going to save pretty close to $1,000, just by using a little shrewdness and saying, no, you got to sell me the car for 22. Somebody's making a little extra pocket change there. All right, let's try another type of paper. So how do you figure these things out? Let me put some equations down here, and we're going to transfer these equations to actually problems. Okay, so I have 3 written down here. What is 6% of 140? So what equals 6%? Change it to a decimal. Of means times 140. So to do this, we're going to multiply 0.06 times 140. 0.06 times 140. 8.4. Okay, just that easy. We're translating. Whenever you see is, what do you put? Equals. Whenever you see of, what do you put? Times. Let's try this one. 63 equals. Change that to a percent. 0.18. Change it. Move 2 places away. Of times. Put a little time sign there. What number? Let's put N for number. Now, here you got a number and a thing on the same side. A number, 0.18, and a variable. So to solve this, what we're going to do, we want N by itself. To undo times, we're going to divide. 0.18, 0.18. We're going to divide both sides. This would give us, these cancel off, and we should have 63 divided by 0.18. And let's see what happens. 350. Well, let's see if that makes sense. Part, which should be small usually, is equal to percent times total. So the total should be bigger. 18% of the total is 63. Okay, 288 equals what percent? Let's put a P with a percent sign. Of 640. Again, variable and number on the same side, we got to get rid of the number. We're going to divide both sides by 640. 640 cancels off. 288 divided by 640. Okay, 0.45. Hold your horses. We're looking for a percent. We found P, but we need that percent. That's why I like to write that down. That's not a percent. So we're going to move this 2 places towards the percent. 45% equals P. You do this on a test, you get it marked wrong, some points off. I do get partial credit, but this would give you full credit. You don't want 0.45, you want 45% because you're looking for the percent. Okay, look at a couple more. Here's something in sports. The Bulls won one year. What was this year? 1995, 96 season. They finished up 72-10. The most wins by NBA team. So we want to figure out what percent of the games did they win. Okay, let's see, percent of games did they win. Okay, so we're looking for the percent, And we're going to write this as kind of a fraction because we can change a fraction to a percent. So they won 10 games. And you might think it's 10 over 72, right? And you would divide it, but you're wrong. If they won 10 games, they played how many games? 82. 82 total games. So they won 10 out of, they won 72 out of 82 games. See, this would give you 72 out of 72, which would be wrong. We want to know how many of the games not lost, but how many did they win? 72 out of 82. And that'll give you the percent. But it won't give you a percent yet because it's only going to give you a decimal, right? 0.72 divided by 82 is 0.878. So we can round that off. We just keep it 0.878. So we found the P, but now we need the percent. So that's, again, we're going to move towards the percent, 87.8%. Or if you wanted to round it off, it would be 88% of the games they won. Okay. One more. Let's look at some income tax here. You're going to figure out your income tax. You earn $53,720. You look it up in some tables that they have. The government has this table sheet. You probably went to an accountant, but maybe you're trying to do it by yourself. And the table says 37,650 to 9,100. Let's see, 37,650 to 91,150, and your amount falls in that category. So it says to pay 5,183.75 plus 25%. You're in a 25% count. That's what they mean. So how much are you going to pay for your tax? Well, what a lot of people might think, they're going to take 5183.75, and then they're going to take 25% of that amount, and then they're going to add them together. But that's not true. First of all, we want to find the change between these two amounts. So you're going to take 53,720 minus the 37,650, and you're going to subtract that. Let's see, what is that? 53720. That's what I like about this calculator. Minus 37650. So that's 16070. So that's what you're going to pay your 25% of. You want 25% of or times that amount. So now you're going to take 0.25 times 16070. So 0.25 times 16070 equals $4,017.50. Okay, so that's the amount that you owe. No, but you don't owe that. You owe this amount plus the 4017.50. You see, you have to add those together. So the amount of tax that you owe would be 4183.75 plus 4017.50. You owe $9,201.25. So that's how this table works. It's not 25% of this amount. It's 25% of the difference in that amount of just this, which is this number right here. So it's the 5,183 according to the table plus this amount. Then you could take off maybe deductions or different things that you take. This is your basic tax that you would pay, less deductions and different things that you can take off. So it depends on how much tax you would actually pay. But according to this, if this was your total column after you added everything together, then this is how much tax you would owe. And of course, it depends how much you have taken out of your paycheck. So what percent does that actually end up? Let's find that out. That should be interesting, huh? You're paying $9,201.25 out of $53,720. Let's see what that comes out to be. Let's try that little division here. 9201.25 divided by 5.3. And of course, this is an older table. The tables have increased since then, even though they say. So 17%, 0.171, 17% of your salary has gone to taxes, just on your salary alone. Okay, so that represents 17% of your salary. All right, I hope you enjoyed this. I hope it's useful. Make sure you try the problems. They shouldn't be too hard. A lot of conversions, just trying those kind of basic things. And I just threw in some word problems here, kind of show you how we can use this, how it adapts very well to that type of thing.